1/3 of all the food we eat today is pollinated by honeybees, which makes the mysterious phenomenon that has crippled beehives across the country over the past 10 years particularly concerning. What have we learned about colony collapse disorder, and how might we reverse its course? Ahead on Wide Angle. Our environment and the countless creatures who inhabit it face many challenges and affronts, most of which are likely invisible to we humans. One crisis we have been able to witness, however, is colony collapse disorder, a phenomenon impacting honeybees and, by extension, virtually every human who eats food. Joining me today to explore CCD and its lessons are two guests. Sainath Suryanarayanan is an assistant scientist of biology and society at the Morgridge Institute for Research. Daniel Kleinman is currently the Associate Provost for Graduate Affairs at Boston University. They are co-authors of the just-released book, Vanishing Bees, Science, Politics, and Honeybee Health, the basis of our conversation today. Welcome to you both.
Thank you for having us.
Absolutely.
Thank you.
A pleasure. Your book has two main aspects to it. Yeah, certainly there's the science of colony collapse disorder, as well as what you call the sociology of ignorance and the social studies of expertise. And I'd like to unpack those for my viewers, and thinking probably the best simply to give the backstory to colony collapse disorder first. In the second half, we can sort of map out this the sociology of ignorance. So let's start with the colony collapse disorder. It first gained widespread use in the U.S. during the spring of 2007, if I remember correctly. Beekeepers across the country are coming to their hives and expecting to find the typical loss, which is, as I recall reading, is about 15% of the bees in the hives. What they found, however, in the spring of 2007 was very different from that. Yeah? What did they find?
Between 50 to 90% of losses were starting to be seen at that time. Since that period, over the last decade, scientists and beekeepers agree that there is a new normal of losses, about 30% average over every year annually.
Wow. Okay, all right. And I suppose that for viewers who are still thinking maybe of honeybees as primarily responsible for giving us honey, which certainly they are, but their role in our agricultural system is considerably larger than just that picture. Yeah, and in fact, it has been from the middle of the last century. Yeah, can you maybe paint us a picture of the central role that honeybees play in the food that we eat?
Sure. So, right. So I think that the average person thinks of honeybees as the creatures that provide them the honey that they spread on their toast. And they certainly do that. But pollination services provided by beekeepers and their bees across this country are responsible for contributing substantially to the productivity of much of the food that we eat in the United States, from almonds to berries to vegetables. Yeah, I mean, this is a central piece of industrial agriculture. It emerges as a thing in the middle of the 20th century when beekeepers go from sort of using the fields of farmers as a way to have their bees collect pollen and ultimately produce honey that they would either eat or sell, to beekeepers realizing that they have something that growers need, pollination services. And so now in 2016, thousands and thousands of beehives are taken on trucks across the country and moved from field to field, and the growers are paying these beekeepers for these pollination services.
Right, and I think that the fraction that I recall from reading in your book is upwards of 1/3 of the food that we eat is pollinated by honeybees. Is that right?
That's right.
All You spoke there, Daniel, of industrial farming and how that led to a significant shift in how food was grown in the United States, and leading to a reliance upon honeybees and their services, their pollination services, if you will. It's been, and certainly the notion of industrial farming, I gather, figures in very closely to why conceivably the rise in colony collapse disorder. Yeah, it's been almost a decade since CCD was first labeled, and I'm wondering if we've made significant progress in mapping out a reason for the onset of this disease in the honeybee population. Do we have a sense as to why it happened, or likely reasons?
So it's not a simple answer, and depending on whom you talk to, you might get a different answer about the significance of the progress so far. Yeah. The long and the short of it is that yes, a lot has been found out about colony collapse disorder in the sense of narrowing down a set of possible factors. So it's certainly not, there's a consensus that it's certainly not cell phones. For some time there was this controversy whether the radiation from cell phones could be affecting and leading honeybees to have a changed sense of navigation, and not coming back to the beehives. So it's agreed that that's not the case. It's not cell phones, but some potential culprits, such as certain insecticides, like the insecticides that we talk about in the book, the neonicotinoids. The mites are still in there as one of the possible factors. Issues with nutrition, as large-scale monocultures have increased, the diversity of nutrition that bees have access to has become a problem. And then also pathogens, the new and emerging microbial pathogens, and synergizing with existing ones. One of the big findings has been that that CCD is not caused by any one of these possible factors, but it's a complex mix of multiple factors. It's a multifactorial phenomenon, and I would say that that's the most significant realization that has come about, but it still remains unresolved which of these factors are more prominent in this complex mix, and how these factors might be interacting to cause colony collapse.
Right. Was there any element in sort of that chain of possible reasons that was introduced in the neighborhood of 2005, 2007 that could be pointed back to as sort of the straw that broke the camel's back, as it were?
So beekeepers and environmental activists like to point to one such uptick, a big upsurge in the area of fields that were sown with seeds that were pre-treated with a neonicotinoid insecticide called clothianidin.
A possibility there. Interesting that it was about 7 years, I think, before CCD was gained that label, that beekeepers in France, the bee community in France, was dealing with something, if not the same, something similar. Yeah, another significant affront to the bee community there. They, however, were able to follow a very different track than we in the United States have since been able to follow. How did they address the crisis in the bee community that they experienced there?
Peter, that's a good question, which really points to some parallelisms and interesting contrasts between the colony collapse case in the United States and a similar issue that happened a decade before, almost, in France. And in that case, It was in the 1990s, during the time when one of the first insecticides called imidacloprid, one of the first neonicotinoids, got introduced in 92. A few years later, beekeepers started noticing that when they took their beehives to sunflower fields that had been treated with this insecticide, their bees were behaving very strangely in ways that they hadn't seen before, showing behavioral symptoms like simply hanging out on a plant without moving much, or spending a lot of their time sitting and scratching their bodies, as opposed to being, foraging for pollen and nectar.
Right.
And some other sets of symptoms that were accompanied by worrying losses. Not exactly like the colony collapses that we saw in the United States, but nevertheless losses, which led to losses in honey production as well. And the beekeepers there tied it through their observations to, again, these neonicotinoids that had been introduced into France.
Right. Now, what they were able to do, I gather, was take this piece of suggestive evidence, yeah? It wasn't definitive evidence that this neonicotinoid was connected to these losses, but there was reason to believe that it may well be, yeah? And they were able to then affect policy. Is that right? Which in the United States, we're having a hard time at the EPA level affecting policy change in trying to deal with this. Yeah? Can you sort of pull that out a little bit for us?
Yeah, I mean, I think that there are probably several factors that are at play here. The first is that the kind of experimental research that the scientists involved with the French government were doing was different. So they were doing laboratory studies. A second, and in the United States, the sort of gold standard has been experimental studies in the field. So on the one hand, they're getting slightly different data. Another factor has to do with the kind of protest that was that occurred in France, right? So in the United States, beekeepers are probably across the board concerned about colony collapse disorder, but they're not mobilized as a social movement, whereas they were in France and collaborated with farmers in their expressing their concern to the government. And then finally, I think you implied this, there is in Europe in general, there is more of an inclination to adhere to a precautionary principle in regulating exposure to potentially hazardous chemicals. And the idea there is, if they could be harmful, even if we're uncertain, perhaps we should consider taking them off the market. And in general, not systematically, not across all time, in the United States, that's not the case. You need definitive evidence that something is causing a problem.
Right, right. All right, let's take a break there, gentlemen, and ask viewers to join us on the other side of this public service announcement. Welcome back to Wide Angle. I'm Peter Bermudez, speaking today with Daniel Lee Kleinman and Sainath Suryanarayanan about their new book, Vanishing Bees. So, gentlemen, in the first half, we talked about sort of the whys and wherefores, a little bit of colony collapse disorder, and what we've seen over the past decade in the States. But I'd like to move us a little bit to explore this notion that you speak to directly in the book, and you title it "The Intersection of the Sociology of Ignorance and the Social Studies of Expertise." Difficult to imagine, so I'm going to ask you to sort of unpack those two separate ideas for us, if you would.
So the book is really fundamentally about why we know what we know about colony collapse disorder and why we don't know other things. And so when we use the term ignorance, we don't really mean naive. We mean not knowing something. And, the premise there is that anytime you know some things, you inevitably don't know some other things. So what we investigate in the book, among other things, is the fact that there are particular ways in which experiments are done by entomologists interested in understanding what's happening to the honeybees. Usually those experiments involve looking at causal factors singly, one at a time. That means that if a set of factors is interacting with one another, if they are, say, weakening the honeybees but not killing them straight off, that those experiments are not going to get to understanding that problem. By contrast, some beekeepers believe, and I think plenty of scientists recognize this as well, that actually it is about these interactions, even though we don't know for sure. And so on the one hand, we're really interested in how it is that beekeepers gain their knowledge about honeybees and how that might be different from the way that scientists do their work. And on the matter of expertise, the sociology of expertise, I think the premise is that although scientists know plenty, you don't need to. Being a scientist isn't the only way to know things, and that expertise comes from a lot of different contexts, and that beekeepers who are in their fields, who look at their hives every day, who monitor their hives, sometimes quite systematically, and compare hives and compare conditions over years, are doing a kind of experimentation and learning things, and we should probably pay attention to them.
Right, right. And let's actually take a look at this on the ground within the bee world, if we can. Now, I gather that certainly in the United States, there is a hierarchy in the bee community. Yes, and I suppose the lowest rung of the hierarchy, if we can establish a vertical scale, is the beekeeper, is the person closest to the bees, actually. Yeah, and it was actually beekeepers who back 2006, 2007 were the first ones to recognize these significant losses. Yeah, that were sort of indicating the beginning of a significant issue. Yeah. Next up on the ladder, is it growers, farmers? Certainly they're a piece of the community, and maybe they're on the same rung. Are they on the same rung as beekeepers?
So I think at least I'm not sure about Sai, but would not want to exactly have a hierarchy that way. Although it is absolutely the case that in our society, scientists and the knowledge they produce has very high status, and the knowledge that other people produce often has less status. Right. I think that's true. But I'm not sure that we'd be inclined to put these different players on rungs. What we're interested in really is looking at and taking seriously the way that beekeepers in particular learn about their honeybees and the challenges they might be facing. And fundamentally, an extension from that is the possibility that they actually might be able to contribute to helping us understand what this problem is, and could conceivably even be collaborating with scientists to help understand it.
Sure. I guess, I'm sorry, Sai.
No, I agree with what Daniel is saying, and I just wanted to add that there are deep historical reasons why these hierarchies have come to be the way they are, cultural and historical reasons. So we explore those reasons certainly in the case of the bee world and how those hierarchies came to be. But again, we don't, like Daniel said, we are not having this stepwise or rung-like placing farmers and beekeepers in these hierarchies. What we can say is that these hierarchies in which beekeepers are finding themselves marginalized, their voices marginalized, that these hierarchies have developed in the context of the rise of a certain kind of agriculture and agricultural research in the United States, where ag scientists in land-grant universities became the purveyors of and arbiters of deciding what is valid knowledge and what isn't valid knowledge regarding honeybee health, regarding other aspects of agriculture as well.
And I guess that's really the reason that I brought up the notion of the ladder and the hierarchy, only to illustrate the fact that there was certainly input being offered by people on the ground, as it were, by beekeepers, that I gather from, at least from my read of your book, wasn't necessarily being taken at the same weight as the input of entomologists and EPA scientists. Yeah?
I think that's fair.
Okay.
Yeah.
All right. The metaphor in my mind was a candle. Yeah. And it certainly casts light, illumination, but it also casts shadow. And I guess those are the blind spots that you're speaking to in relative to the ignorance that is also being produced, just depending upon the means of gathering information and knowledge that we use. Is that right?
Right. So if you don't end up taking seriously the ways in which beekeepers are gathering data about their honeybees,
Yeah.
if you don't take seriously the measures they use to understand loss and health and so on, you're losing information.
Right, right, exactly that. And of course, we bees, as well as all of us, stand to lose as a result of that lost knowledge. Yeah.
Definitely.
Now, the two of you are conducting field work, an experiment, wherein you're hoping to advance our understanding of citizen engagement in knowledge production around this specific issue, colony collapse disorder. And I'm imagining that by extension, that would sort of hold for other areas of inquiry too. Yes? How can citizens, regular citizens, not necessarily citizens who possess academic degrees, academic credentials, years of academic learning, how can they contribute to this knowledge base? Can you tell us a little bit about the work that you're doing and what you're finding as a result?
So very broadly, we were interested in asking, can non-scientists and scientists collaborate in genuine ways to understand complex phenomena like bee decline? Especially in the cases where there is a fraught history of conflict and cooperation between these non-scientists of various kinds and scientists. So in this case, beekeepers and growers sharing a century-long history of not only cooperation but also tensions in client relationships. So the experiment was, in that sense, a social one, in trying to bring together the various stakeholders from the bee world, including beekeepers, growers, various kinds of scientists, including entomologists, honeybee biologists, landscape ecologists, as well as governmental, non-governmental policymakers. So bringing these people together, can we have genuine collaboration between them? Can we set up a structure of deliberation in which they can collaborate?
Okay.
That is a social experiment, and the biological experiment being that can this genuine collaboration then lead to a way of making knowledge that would allow us to better understand the complexity, the social and ecological complexity in which honeybees are dying.
The punchline here for us is that when we brought these groups together over 4 deliberations, what we found was across time they learned to trust one another, and the kind of hierarchy that you referred to, Peter, at the outset dissipated just a little bit, not completely, but the beekeepers in particular felt emboldened to articulate positions, to generate hypotheses, to talk about measurement and so on. And the scientists were very interested in what the beekeepers had to say, and the field experiments that the group subsequently designed reflected input from all the different players.
Right, good. Is it your sense, gentlemen, that we are at a place, 10 years after sort of labeling this, are we at a place where we're conceivably making some progress and where input is reaching an environmental protection agency and there's conceivably there are policy decisions being made that could resolve this to some degree?
One of the messages from the book is that this is a complex problem and that a simple solution will not do. What Sai was just saying is that particular message has probably not gotten through. And frankly, we see it even with environmental groups. I just in yesterday's mail received something, from a national environmental group said, "Save the bees, get the neonicotines off the market." It's not necessarily wrong to think about reducing exposure of honeybees to these chemicals,
right.
But that is just, it frankly is oversimplifying a really complex problem, and that if we really want to address that problem, we have to think more broadly about what's happening in industrial agriculture and what kinds of things we might undertake to create a more sustainable system.
Well, gentlemen, I thank you both for taking the time to speak with me today, and as well for putting together Vanishing Bees and encouraging us to take a deeper look at this problem and maybe look at it in a slightly different way as well.
Thanks
Our
for
pleasure.
inviting us, Peter.
Yeah,
Absolutely.
thank you, Peter.
In the heyday of coal mining, caged canaries were employed to detect dangerous levels of carbon monoxide before such gases also claimed their subterranean captors. And maybe that's a fitting metaphor for honeybees today, sensitive enough to our chemical concoctions and manipulations that they perish before we do, sending us a message, though a bit more complex than the one canaries sent miners, that we might nevertheless surmise and heed. Would that their loss not be in vain. For Sainath Suryanarayanan and Daniel Lee Kleinman, I'm Peter Bermudez. Thank you for joining us for this edition of Wide Angle.